Here we are then in lesson 6. Now, I think we need to get down to some kind of operators as well as anything else. So I think it's time to say goodbye to our old friend down here. Let's get rid of this thing here. We know this works. We don't need this check anymore. Now, what I'd like to do is actually take all this information that we've calculated, we've entered, we've calculated and so on. And now what we can do is we can start figuring out what the payment should be, the monthly payment for this 30-year mortgage. Now, we'll just use the standard figures later on. Those two warnings, by the way, here are just telling us we're not using those variables. So let's use them. First thing we need to do is we need to set up a variable to soak up the payment, the monthly payment for this 30-year mortgage we've been doing. What's this monthly payment going to be? Super. Now, we've set up our variable with a nice empty air value. Good stuff there. You can find these formulas anywhere on the internet. Just search for amortization formulas and you'll find this formula as a standard formula. So we're going to set payment is equal to the principal figure that we've calculated earlier, or we entered actually. That's going to be multiplied by, now I'm going to try and keep this as neat as I can, the monthly interest. Now, we'll put that bracket back on later, divided by 1 minus. Now, we're going to have to use a special built-in C++ function here called power. It's very similar to the power function in Excel that you might have used. This is where we're going to raise something to a certain power. So you take a number like 4 and you raise it to the power 2. 4 squared equals 16. I think in Excel it's called power. Here it's called pow. This is just just a formula I've just taken off the internet. It can be any formula you want from anywhere you have. And this power, let's put all these brackets back in later. So the first number is 1 plus the month interest. And then that is raised to the power of minus. This special minus symbol will make any number following it into a negative number. So we're raising to a negative power. We are going to have months of loan, which is this one here, which is great. So that's the end of the power. That's the end of this particular function. That's that bracket there. That's that bracket there. Bob's your uncle. And what we'll do is we'll just output this information. The monthly mortgage payment, I'll just write payment to keep it short. Every month, for 30 years, you'll be making a payment for this mortgage of, remarkably, payment. And then we'll need a new line character just to make everything neat. Now, this isn't going to work. Now, it's interesting to find out why this isn't going to work. Let's give it a go. Build failed. Why? Because C++ is good because we can be very tight with it. Although this is a built-in function, you don't load all of C++ all the time. You only load in what you need. It's on a need-to-know basis. Does James Bond need to know? Here he does need to know. So what we need to do then is add a special kind of library, which always comes with C++, but we don't. You've got to load it explicitly in case you, just to save yourself memory. Now that should give us the power. It knows what it is now. So let's give it a run. Again, this will fail, but for reasons which are interesting. Now, call to power is ambiguous, raising one power number to another power. 4 squared equals 16. Why? Because this is expecting several different types of variable, either a float and a float together, or a second function called power is expecting a double or a double. That's called overloading, and we'll talk about that when we get to object orientation a bit more. But here we've got month interest, which is a double, and 1. 1 plus month interest will come back as a double. And then we've got months of loan, raised to the power of minus months of loan, 360. The problem with that is that's a long, or it could be an int, or even if it's a float, it just doesn't know what to do. This should be a float and a float, or this should be a double and a double. So what I'm going to do, some people may groan at me doing this, but I'm going to do it anyway. I need to cast these variables and turn them explicitly into doubles so that we don't confuse the program. So I have to say that this number, try and highlight it, this number here, 1 plus month interest, I'm going to say this is definitely, this should be converted into a double. And that's how I do it. I say, please make this a double. So if somebody walks into a bar and says, there's a gin and tonic, I say, no, 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 please make it a double gin and tonic. There we are. And the same thing over here with this long. I need to cast it. I need to just put this on the next line, keep it nice and visible. I need to cast this as a double too, just to tell Pout, listen, I'm giving you 2 double gin and tonic. There's a double gin and tonic there. And then there's a double vodka martini. Yes, I know it looks like just a martini, but it's actually a double vodka martini. Let's just check we've got the right number of brackets. That's good. And then that, and then that, and then that. Super. And now we can, hopefully, fingers crossed, this will run unless there's an error, which we can investigate. Build succeeded. Lovely. Okay. 100,000. Enter the interest rate 5% over 30 years. What's the monthly payment? The monthly payment, $536.82. Now, any of you have a financial... I'm not going to put dollar symbols in and everything else. It could be any currency, euros or gold ounces or anything you like, really. What we'd like to do is we'd like to format that, though, so it's 0.82, so it's only 82 cents or 82 pence or 82 gold grams or whatever currency we're working in. Those from a C background will know about printf and things, but you shouldn't really mix the output and inputs of C++ and C. Although C is all within C++, it gets very messy when you start using C input and output functions and C++ input and output functions. You should always try to stick as much as you can to what's built in, and that's the cout and the cin, the black hole and the white hole. Sprintf is a different matter, because what sprintf is going to do later, we're going to format strings and then output the using the cout. That's probably okay, but we really shouldn't be doing printouts and printfs. So let's just have a little look at a little bit of crazy C++ style formatting. This is what you do here. To get this payment to come out right, to come out with 0.82, you need to basically set a precision. So what you do is inside the middle of this cout chain of commands, you say, for the following number set payment, set the precision of it to 2. So basically payment's coming in here, and it goes to the left. And it gets a kind of a wrapper stuck on the front of it saying, please set the precision of this thing to 2, please. And so C++ will do that. Now, again, this is going to fail. Let's figure out, let's just check that. Yeah, it will fail. Now, the reason why is we need another library. So let's add our third kind of global C++ library. And that library there is iomanip, which is input-output manipulation. Ooh, Bluetooth, what's that all about? Manip. Super, there we go. Input-output manipulation. Should recognise it now. Should recognise set precision. So let's have a little crack at this. 100, 1, 2, 3, 5, and what did we say? Years of land 30. Now that's no good, is it? I mean, what use is that? That's just horrible. And that's because set precision is it doesn't care about what comes around the decimal point. The decimal point isn't fixed with 2 characters following it. It's just trying to print out 2 characters if it can, or as small as possible. So that's no good. So we have to set another wrapper around payment. So payment gets 1 wrapper, which is this thing, and we're going to add another wrapper. I probably need to just nip down to the next page, next line. And the next wrapper is going to be set input output streams, input output streams fixed. And these are flags which say keep the decimal point in a particular position, and yes, set the precision to 2 for the decimal points, but we need to do this. Now, this gets very messy, so I'm going to use printf later on for some bigger formatting deals. But this is okay for now, and this should, if fingers crossed works, this should give us the right kind of look. So you can see, we don't want this. This is, I mean, what use is that? You can't say that down the phone to somebody. By the way, Mr. Duncan, your payment will be 5.4 times e to the power 10 squared. What use is that to me? Okay, so let's give this a run. Oh, Bill fell. What have I done wrong here? So, use of undeclared expression. Oh, sorry. Set iOS flags. There we go. That should hopefully fix it. Bill failed. What's gone wrong here? Set precision 2, expected expression. Oh, I've got 2 of these, haven't I? I need to just. Yeah. Will that work? Hooray! Now, let's give it a go. Years of loan, was it 30? There we go. We've got the nice 82 cents there, which is great. $536 and or Sing dollars or Hong Kong dollars or pounds or euros, and 82 cents. Lovely jubbly. So in this lesson, what we've seen is we've seen some operators, some multiplication, division. We don't, in some languages they have that's an exponentiation function, but C++ doesn't have that, because that, I'm afraid, is going to be pointers, which we'll see a lot more of coming up soon. So we do have to use this POW thing. It does want things to be explicit. It needs to know what's coming. I mean, this would be fine if these were both doubles going in, but just to make sure, say, please turn that gin and tonic into a double and that vodka and tonic into a double, just to make absolutely sure it knows what it's doing. And that is that. Oh yes, we've also got the cmath for that power function, an iomanip for everything to do with input-output manipulation. Thank you, and see you later.